Hi viewers, this is Sri Ramulu, a degree lecturer in physics. My YouTube channel is S.S Space Physics. Dear viewers, before watching this video, please subscribe it, like it, comment also. If you have any doubt, comment it, and don't forget sharing this video to your friends. Okay, friends, thank you. Now the topic is ratio of specific heats. So, what is the ratio of specific heats? First, specific heat definitions. We have the two different types of specific heats. One is specific heat at constant volume. Second one is specific heat at constant pressure. What is the specific heat at constant volume? And see here, the specific heat at constant volume is, from here its definition, amount of heat required to raise temperature of 1 gram of gas through 1 degree Celsius when volume of gas is kept constant. It is denoted by Cv is equals to dou Q by dou T. Okay friends, once again, it is what? Amount of heat required to raise temperature of 1 gram of gas through 1 degree Celsius. Okay, suppose let there is a gas, let it is a gas, it will contain the gas, and what I am doing, I am applying the heat, I am supplying the heat to this gas. Initially, before supplying the heat to this gas, let's its temperature is example 27 degrees Celsius. It is room temperature generally, so that is why I am writing this one 27 degrees Celsius. And my aim is what? I want to increase its temperature from where to where? 27 to 28 degrees Celsius. Then how much degree I want to raise? Just to 1 degree only. And its gas is 1 gram gas only. To the 1 gram gas, if you increase its temperature 1 degree Celsius, then how much heat is required? That heat is called specific heat. Okay friends, so specific heat is a heat just to increase 1 degree temperature for 1 gram. How much heat is required? That heat is called specific heat. If you are doing at constant volume, specific heat at constant volume. If you are doing this experiment at constant pressure, then specific heat at constant pressure. That's it only, nothing will there inside. Okay, now once again let me read specific heat at constant pressure. The specific heat at constant pressure is the amount of heat required to raise the temperature of 1 gram of gas through 1 degree Celsius when the pressure of the gas is kept constant. Okay, here amount of heat required to raise the temperature of 1 gram of gas through 1 degree Celsius only. Okay, so it is a formula. Cp, Cv having the both formula same, but their constants are different. Cp means constant pressure, Cv means constant volume. Only volume and pressures are different, but remaining all are same. Okay, bulk modulus. What is a bulk modulus? Bulk modulus, rigidity modulus, and shearing modulus. So like this, we have the different types of modulus: Young's modulus, bulk modulus, and rigidity modulus. So what is first modulus? Modulus means stress by strain generally. Okay, modulus means stress by strain. So it is in intermediate, it is not a higher education. Stress by strain. Okay, stress means what? For bulk modulus, let me denote with E. Okay, modulus, bulk modulus or modulus, let me denote with E. For especially bulk modulus is related to the volume only. Okay, Young's modulus related to length, rigidity modulus related to area, bulk modulus is related to volume. Stress means what? Force by area. It is called stress, force by area, and this force by area is also called as pressure. Am I right? Force by area is also called as pressure. So that means stress is nothing but pressure. Okay, stress is nothing but pressure. By strain means what? Strain formula is what? Strain. it has a separate formula strain. So strain is equals to change. Actually strain definition is change by original, change in dimension by original dimension. What is the change in dimension? So it is related to the bulk modulus, means change in volume by original volume, change in volume by original volume for only bulk modulus. If it is Young's modulus, change in length by original length we will get. For rigidity modulus, change in area by original area we get, but it is related to bulk modulus volume we have to take, change in volume by original volume. And here minus we have to write. Why? Because for example, initially it is a body like this having volume V, and if you apply the pressure on it, so pressure or stress on it, then what happens from all side? Its volume may decrease certain time, so its volume decreases. Am I right? From all side, if you apply the pressure or from all side, its volume decreases. So decrease in volume is denoted by minus, and that is how much? Dou v by dou v, that is. So that is why change in dimension by original dimension, change in volume by original volume. So here dou v by dou t we have to write. Dou v by dou v by v, not dou v by dou t, dou v by v minus it is. Then from this p by what? P by dou v by dou v by v means simply we write pv by dou v and minus. So see, alright, and this p is taken as a dou p, small pressure is taken, small pressure, so that is why dou p. So it is like this, minus v dou p by dou v. Okay friends, it comes like this. So here negative sign indicates the increase in pressure, decrease in volume. So volume decreases when pressure is increases. The adiabatic, so this one, to this one I am going to apply two process. One is for isothermal process, and next for adiabatic process. Okay, isothermal process means a process which takes place at constant temperature. Okay friends, isothermal means a process which takes place at constant temperature. Adiabatic process means the process take place at constant heat energy. Okay, heat energy is constant, but according to TS diagram, I explained you TS diagram, so please watch the video TS diagram. In TS diagram, in adiabatic process entropy is constant, right? In adiabatic process, okay, in adiabatic process entropy is constant. In isothermal process temperature is constant. Here entropy constant, temperature constant. Okay, so to this I am going to apply adiabatic relation and a isothermal relation. Adiabatic at constant entropy, so that is why here constant is written. Okay, to this no, only like this, and it is for this, so it is like this. Okay, it is isothermal elasticity, adiabatic elasticity. So bulk modulus of elasticity, its full name is bulk modulus of elasticity or coefficient of volume elasticity. Okay friends, now it is equation 2 and 3. Write S by T, equation 2 by 3, equation 2 by 3 it is equation 2, it is equation 3, 2 by 3, and here we cancel. Then dou p by dou v at constant, yes, dou p by dou v at constant t. Now for this what I am doing here, in numerator I am going to multiply and divide with a dou t, only numerator dou t. Why sir? Whatever constant here present, with this constant multiply above, with this constant do the same thing below, same thing here, whatever things you do, same thing do downside. So here it is at constant temperature, so that is what I am doing. I am going to multiply with dou t and dividing. So here multiplied and here divided. Okay, so dou p by dou v, it is see, dou p by dou v, so written like this, separated dou p by dou t by dou v. If you cancel it again, you can get dou p by dou v. Now downside dou s, just now I told you dou p by dou v, it is dou s by dou s and dou s multiplied and divided. dou p by dou s, dou s by dou v at constant temperature. Next, and separated here, right? It is, this term is separate and this term is also separate. So upside two things and downside two things will become, we get. And s is right here and here also, t right here and here also. So same thing is done here. Okay friends, now right now see here. Okay, now see, separated like this. Now applying the Maxwell's relations we have here, what I am doing, I am going to apply the Maxwell's relations. Okay, Maxwell relations for all the things, for this and this and this and this. For four equations I am going to change, these four equations I am going to change by using Maxwell's relations. So before that what we have to do, we have to draw the here logic which is explained in Maxwell's relations. So it is my logic, please watch the Maxwell relations. Police station, TV, which channel, G channel. So equation 1, 2, 3, equation 4, minus minus, these two are plus and plus. Okay, what is this here? Dou p by dou t we have, dou p by dou t. Where is the p here? Dou p by dou t, p by t is there, p by t, p by t means like this. Okay, like this means it is third relations. Which side? So here we have to imagine we are this side. Okay, we are this side. P by t can be written is equals to s by v, right? So that is by c, in the place of p by t, dou p by dou t, dou s by dou v is written. Okay friends, right? It is, this minus not belongs to this one, this minus are belongs to this one. Okay, now so this equation is converted into like this. Okay, this is converted into like this. Okay, next this one, t by v, where we have t, here we have v here. T by v means like this, we are moving, means we are this side. Okay, that means first equation, equation 1. So t by v is equals to p by s, dou p by dou s. P by s means dou p by dou s. So t by v can be written as p by s, but it is the first equation is minus, so that minus is written this side. Okay, so this is written as like this. Next this one, p by s, p by s, p by s is equals to, it is t by v. This by this means this by this, so t by v, dou t by dou v. Next, so this equation written like this. Next this is, see, it is like this. How? S by v, s by v, s by v means in this direction, means we are this side, so that means third equation it is. P by t we have to write dou p by dou t, where dou p by dou t. Okay, but dou p by dou t, so it is a minus. Which equation that is? It is what? P by s, p by s, t by v, that is a minus, it is minus here, and this minus gets cancelled. And see, it is a p, it is p, it is v, it is v. So pp, right, common to this one, common to both, and v here, vv common here, right, common term. Okay, so right like this, it is a common, and it is like this by this, this by this, and this by this, in between them in multiplication. Okay, now what thing cancel here? V cancel and V cancel, dou v cancel here. What? Dou p cancel, dou p and dou p cancel. So here dou s by dou t remains, dou s by dou t at constant pressure, and here 1 by s and 1 by t means t goes upside, so t by s we get. Okay, 1 by s, 1 by dou s, and 1 by dou t means dou t by dou s we get. Okay, reciprocal here, dou t by dou s. Okay friends, like this. And right, it is, now it is, these two are in multiplication, these two are in multiplication, right? It is a denominator to it, means take it is simply reciprocal. Dou t by dou s, write it as dou s by dou t, then it becomes denominator. Okay, it is in numerator. Okay, now on either side multiply with t. Here and here multiply with t, multiplying numerator and denominator by t, so tt, and multiply this t inside, in t inside, do t do s is do q, t do s is do q. It is the second law of thermodynamics. Okay, here also do q, and but our formula is beginning at the beginning, our definition cv, do q by do t at v is cv, do p by do t at p is cp. So same thing we got here, do q by do t at p is cp, do q by do t at v is cv. So this ratio is always equal to gamma, cv by cv is gamma, already is proved in lower classes, that is in intermediate. Okay friends, so it is completed. Don't forget watching this video till the end. Okay friends, thank you, bye.